1. The Moon was formed from a giant collision. Scientists believe the Moon originated around 4.5 billion years ago from a catastrophic collision between the young Earth and a Mars-sized body called Theia. The debris from this impact coalesced over time to form the Moon. This explains why lunar rocks are remarkably similar to Earth's crust. The Moon is slowly drifting away. The Moon is moving away from Earth at a rate of about 3.8 centimeters, 1.5 inches, per year. This phenomenon, caused by tidal interactions, gradually increases the distance between the two celestial bodies. Over millions of years, this drift will have profound effects, such as lengthening Earth's days and altering tides. The Moon's gravity causes Earth's wobble. While the Moon's gravity is well known for causing tides, it also stabilizes Earth's axial tilt. Without the Moon, Earth's tilt could vary chaotically, leading to extreme climate changes. The Moon's presence ensures that our planet's seasons remain relatively stable over long periods. There are moonquakes. Just like Earth has earthquakes, the Moon experiences moonquakes. These seismic events are caused by the gravitational pull of Earth, meteoroid impacts, and thermal expansion due to temperature fluctuations. Some moonquakes can last up to an hour, making them quite different from their terrestrial counterparts. The Moon has a thin atmosphere. Though often described as airless, the Moon does have a very thin atmosphere called an exosphere. It is composed of trace amounts of helium, neon, argon, and other gases. This atmosphere is so tenuous that it offers no protection from solar radiation or meteoroids. The Moon always shows the same face. The Moon is tidally locked to Earth, meaning its rotation period matches its orbit around Earth. This synchronization causes one hemisphere, the near side, to always face us, while the far side remains hidden from direct view. The far side, often mistakenly called the dark side, receives sunlight just like the near side. The Moon has water ice. In 2009, scientists discovered water ice in permanently shadowed craters near the lunar poles. This water ice could be a vital resource for future lunar exploration, providing drinking water, oxygen, and even rocket fuel. The Moon has no magnetic field. Unlike Earth, the Moon lacks a global magnetic field. However, some regions of the lunar surface exhibit localized magnetic fields, which are remnants of a magnetic past when the Moon had a molten core. Lunar dust is surprisingly hazardous. The fine dust on the Moon, called regolith, is sharp and abrasive due to the lack of weathering processes. It clings to surfaces, including spacesuits, and can pose health risks if inhaled. Future lunar missions will need to address this challenge to ensure astronaut safety. 10. The Moon influences animal behavior. The Moon's cycles affect the behavior of many animals on Earth. For example, certain marine species synchronize their reproduction with the lunar phases, and some nocturnal animals are more active during the full moon due to increased visibility. The Moon is key to understanding Earth's history because the Moon lacks an atmosphere and weathering. Its surface preserves a record of asteroid impacts dating back billions of years. By studying the Moon, scientists can infer the history of Earth's early environment, which has largely been erased by geological processes. The Moon was once closer to Earth. When the Moon first formed, it was only about 25,000 kilometers, 5,500 miles, away from Earth, much closer than its current distance of 384 to 400 kilometers, 238,855 miles. This proximity caused massive tides and contributed to the early evolution of life on Earth. Lunar eclipses are gradually changing as the Moon moves farther away. The duration of total lunar eclipses will decrease over time. In about 600 million years, the Moon will be too distant to completely block the Sun, making total solar eclipses a thing of the past. The moon affects Earth's length of day. The interaction between Earth's rotation and the moon's gravitational pull has been slowing Earth's spin. Over billions of years, Earth's days have grown from about 6 hours long to the current 24 hours. The moon was instrumental in space exploration. The moon has served as a proving ground for space exploration. The Apollo missions of the 1960s and 1970s not only advanced our understanding of the moon, but also demonstrated the feasibility of manned space travel, paving the way for future missions to Mars and beyond. The moon remains a source of fascination and scientific inquiry. Its unique relationship with Earth shapes not only our planet's natural rhythms, but also humanity's aspirations to explore the cosmos.